Hello, everyone. Welcome to Office and XAML, putting it all together. I'd like to thank you all for coming, and this session is also being streamed on Channel 9, so I'd like to thank the audience watching online as well. So today, I'm Jason Morris. With me today is Andrew Coates, and we're from the Office Core Experiences team, Office client, effectively, and we work on building universal Office apps out of our legacy C++ code base. So at the end of the session, we'll bring up the evaluation slide. This is standard, but please evaluate the session. We'd love to hear your feedback, and we hope this session really is useful to you. So today, the main focus is going to be on our approach to universal applications, how Office built the suite of universal applications. We're going to talk about high-level approach, some of our philosophy. We're going to dive into details as well. While some of the stuff we do is a little esoteric, we're going to try to have enough details, especially in the realm of integrating with C++, integrating with your legacy code, and integrating with some of your high-value content. I will start off by talking about our values, our approach. This is sort of the context or the lens through which we view building these applications. And then at the end, I'm going to talk about where the applications are today, how they're going, what our approaches are, where you can get them, various things like that. So to start off, throughout the conference, and I've been sitting in on sessions as well, there's been a lot of great stuff about it's really easy to build applications. It's really easy to do this. You can do all of this stuff really quickly, and that's great, and that's actually really great for developers. But from the Office perspective, we don't care about easy, or we do, but it's not our top priority. For us, quality of experience for the user trumps everything. And if it's more expensive, we're willing to pay that cost. We're willing to do that if it yields a better experience. So to start with background on Office, and I know everyone has some opinions and previous background on Office, but there are many words people use to describe Office. Some of them positive, some of them maybe not so positive. I see some smiles out there. I'll put up some more positive words for it so that we don't have any suggestions. But functional, powerful. We're talking about Office, the desktop version, the Win32 version, classic Office in this context. And it is big and complicated. It can do a ton of stuff. It has a ton of power. And we really believe in the value of that even today. But when you talk about mobile applications, that maybe is not what you're looking for. If any of you saw Mark and Kieran's talk yesterday about XAML performance, they used an analogy of building a car. And when you build a mobile application, you want to build a sports car. You want to build a high-performance, fast and light car. Well, Office isn't really a sports car. Maybe more like a bus. Now, maybe not this bus. It's more like an executive coach. Or if Air Force One was a bus, it would be that bus. It's got features. It's got satellite hookups. You can live your life in that bus. But it's not small and nimble. And we have gotten it to go pretty fast. Considering how big it is, considering how much it does, Office actually really boots and moves along pretty quickly. I did look for rocket bus slides, but apparently that was not available on the internet, shockingly. So when we talk about Office, and we talk about it in mobile context, people just don't think of it as fast and light, and that's something we really need to change. Looking at our code base is an all-native code base. Now, we have some managed application code for extensibility, but in the normal code flow, it is completely native, and that is mostly C++. It's 30 years old. It started off as predominantly C, and it's evolved over that time. The new standards in C++ are actually really exciting to us. People are changing code over quickly. The way we do things are changing. And it's something that this code is old, but it continues to evolve. And I'm sure for many of you who have large legacy code bases, that's true. It's not completely static. It has grown, though. It's gotten bigger and bigger. And right before I set up this deck, I asked for a current count, and it was 171 million lines of code. That doesn't include assets. That doesn't include comments. That doesn't include anything except for code. And that's a lot. It's worth mentioning that Word is not a 55 million line application. This includes Publisher, it includes Project, it includes Outlook, it includes web apps, it includes a ton of stuff. Office is really a broad suite of applications and tools. And most other platform versions have been forks in the past. So this 171 million lines does not include, like the Mac version, does not include the iOS version, does not include the versions we've put out on other mobile platforms in the past. We've had successful releases on those platforms, but we've done it by forking code. So this used to be okay, but over time, the business has changed. So when you look at the Office business, originally we sold Office to machines, and you would get your box of Office, and you would have your 21 disks or whatever it was, and you'd have 2 hours of bonding time with your machine where you switch those disks around. And maybe you install it in a bunch of machines, but that's not really the way that things are done anymore. Now, some of the single machine installs have gotten admittedly better since that day, but increasingly, we're selling to people. And this means a couple different things. This has some very important ramifications for us. Satya used the term portability of experience in the keynote, and I think it's a great phrase, and it's one that really resonates with us as well. The experience of Office, if we're selling to you, if you're buying Office, there's sort of a contract between us and you that we're going to try to get Office wherever you are. If you're using a mobile device, it should be on your mobile device. If you're on a web page, you should be able to access your documents on a web page. If you're on the rich client, if you're on your laptop, then you have a different way of accessing it. You have classic apps. If you're on a Mac, you have ways of accessing it. Wherever you are, if you're a customer of Office, we should be able to reach you. And those experiences should be consistent across those platforms. It should feel like Office. And it's a fine line. It should also feel like the application or platform it's on, but fundamentally, people shouldn't have to figure out how to learn it again. It should be a consistent experience. And when we roll out new features, like we want to innovate. We want to continue to innovate in the classic desktop. We want to innovate in mobile. But when we add those new features, they need to be able to be deployed to other platforms quickly. We can't finish it on one platform, fork it over, have another team somewhere go and modify it, and then release it 6 months, 9 months, a year later. That just can't work anymore in the current business. So going back to the what do we care about? If we don't care about easy, for mobile, and in particular for these universal applications, we care about changing the adjectives. We want people to think of it differently. We really want to build that sports car or luxury sports sedan or whatever. We want it fast and fun. And if not fun, at least a pleasure to use. Creating your presentation or your document may not be fun, but it can be a pleasure. The apps themselves can feel good, can feel light, can feel like they have power, but that power doesn't get in your way. We also care about sharing code. We really need to make sure we're not doing this forking, we're not duplicating efforts, because if we want to roll things out, we have to have a shared code base. We still need to leave room for differentiation on platforms. People who are on a platform expect certain things on that platform. You've heard a lot about the new features on the Windows platform, and there's some really cool stuff on that, and we need to leave room that we can extend the apps on those platforms, take advantage of those great platform-specific features. And we do care about development speed. It's not quite true that we don't care about easy, but we have a lot of developers, and if we can build complex and somewhat dubious solutions centrally and then roll them out to other people, we'll do that. If we can build something complicated and expensive once, and it saves us time or has a better experience, we'll make that trade-off every single time. So looking at how we actually use the platform, we started these applications in the 8.1 timeframe. And in that timeframe, this is pre-threshold, or pre-Windows 10, sorry. The central question was, we're going to build XAML applications, and how do we use those applications as fast as possible? It's very hard to retrofit performance. If you're building an app, it's much easier to get everything right from the start. And so the question became, how do we use XAML as fast as possible? So the first one we came to was traditional data binding was just way too slow. Hopefully you saw the Xbind presentation. If you are a XAML developer, use Xbind. Transition to Xbind. If your app code is structured in such a way that it can't support Xbind, change your app code so it can use Xbind. If you still can't do that, use code behind. It is a dramatic performance boost to avoid data binding. We'll talk about how we solved that. We probably would have a solution based around Xbind now if it had been available, but we'll talk about what we did do. Don't make every property a dependency property. Some of these features are really nice, but custom dependency properties are slow. Don't have that be a foundational piece of your app. It'll slow things down. And then this one seems obvious, but the truth is, it's still an easy thing to make a mistake on. Be cautious with the number of elements you create. Use the things you need. Collapsed visual trees still have cost. Dynamically create those, especially if they're large. You can do it in code behind. In Windows 10, you can use Xdefer load strategy. It's actually a really great solution for that. If you're supporting 8.0, 8.1 apps, having large VSM trees has cost. That's been largely addressed in Threshold. But if you're on those older platforms, it's important to note that especially in elements or in content that is scaling with user data, and that's sort of our own internal rule, if content is proportional to data coming in from a user, if it's not bounded, really avoid data binding, really look at your templates, look at everything, make sure you have no extra elements. At the end of the day, that's your cost, that's your performance cost. And then don't be afraid of code behind. Many of these things, it's nice to get something that works entirely in markup. But if you're trying to really optimize the experience, code behind is really a tool that gives you absolute control and absolute power. And many of the performance improvements can't be obtained without code behind. And Xbind, as an example, is essentially generating very particular code behind for you. And it makes a huge difference to you. So don't be afraid of code behind, particularly if you are on 8.0 or 8.1 and have to do down-level support. So to talk more about data, I'm going to have Andrew come up.
Thank you, Jason. Hello, everyone. So I want to talk a little bit about how we work with data in XAML. So as Jason mentioned, and you've probably heard by now, data binding in XAML is not the most performant way to get your data into XAML. And as he also mentioned, back when we started on Windows 8.1, Xbind did not exist. So when we were looking at building these universal Office applications, when we were looking at how to get our data into the XAML, really the only efficient way to do that was to use code behind. One of the great things about using code behind is since we're using C++ CX, the code behind can talk directly to our existing native data types. So we don't need to wrap everything in ref classes or inspectable or generally create additional wrappers and take performance costs for that. But also, if you have as much UI as we do in Office, you end up writing a lot of code behind to get your data into the UI if you're not using data binding. And so we wanted to look at a way to help our developers write all that code behind, because a lot of that code behind, it ends up being fairly repetitive. It's basically the same code over again. You're listening to properly changed notifications. You're doing switch statements. You're registering callbacks, unregistering callbacks. It's fairly boring code to write. So what we came up with was a custom solution based on a bunch of custom markup in our XAML files that we call XAML scripting. And basically what we do is we pre-process our XAML files during build. And so our custom markup in our XAML files defines three basic things. It defines a set of properties that we are going to expose from our control. Then it defines some scripts, which are really small segments of code behind that will actually do the work to push that data into the XAML elements. And then the markup also defines when we want those scripts to run. And then from this markup, we generate all of the code behind that is the sort of boring, repetitive code behind that you would have to do by hand if you were writing it. And this is really very similar to what the XAML team did with Xbind, we showed them our solution and shared our feedback and insights on based on what we did to help them influence their design. So this is a quick glimpse of what some of our XAML looks like, which really doesn't look a whole lot like normal XAML. So here we're defining a property. We're saying this control has a property. It's of type unicorn. It's called user. And then we have a script. And this script basically says, I'm going to take the name from that user, and I'm going to set it into the text of this text block. And that will just become code behind, standard CX code in the code behind. And then the last thing it defines is a trigger that says when we want that script to run. And that's going to say, here we're going to say it's going to trigger when the name of that user changes. And so if you look at what this script is really doing, it's basically the same as what xbind allows you to do. It's a little less XAML looking, but we were working outside of the platform, so this is what we came up with. So we rolled this out to the whole Office org that was working on XAML UI. And it really performed what its goals were quite well. That the main goal of this XAML scripting thing was to avoid using data binding and to get the performance gains of not using data binding and using code behind instead. And this should be similar to what you see if you switch to xbind. I think when we switched Calendar, which is one of the more XAML-heavy Office applications, and they have a lot of data binding, when we switched them from data binding to our XAML scripting solution, we made our boot 50% faster. So it does make a big difference. But there were some other effects of this crazy scripting solution. One thing is, when we were designing it, we really wanted it to be a replacement for data binding. It was supposed to be for pushing data into your XAML. But we were allowing people to write write code in the UI files. And so once we have that code in the UI file, it became a convenient place for people to start adding logic. And so over time, more and more code got added to the UI files. And that obviously becomes code that is UI specific, it's platform specific, and it's hard to unit test. Which really brings us to, well, how should you be building UI? And really the most fundamental thing is your business logic should be separate from your UI. It's really important to have a good boundary here. And this has always been true. And we change our UI far more frequently than we're changing our business logic. Hang on just a second. And you really don't want your business logic mixed up with your UI when you're constantly rewriting your UI, trying out new designs. But in today's cross-platform world, it's even more important that your business logic is not in your UI, because you really want to be able to share that business logic across multiple platforms. So you take your business logic, you put it in its nice own little object. But then to really enable sharing of that business logic, you need to watch how you use that business logic. You can have your UI talk to the business logic, but you really don't want your business logic directly talking to your UI. It means you can't replace your UI with a different implementation. And again, it makes unit testing or implementing a completely different UI on another UI platform very difficult. And so if you follow this allows you to share your objects, share your business logic. So as I mentioned, a lot of people started writing more code than we really wanted in our UI files. And part of this was because the markup generated a bunch of useful code. And I think developers are fundamentally a little lazy. And so if they have the choice between writing it in the UI file, which is going to generate all this code for them, or manually writing all this code, they're going to pick the one that will generate code for them. So we're moving to a world where we're actually going to use markup for generating our view models as well. So we're going to define our view model, define what properties and events exist on our view model, and then we can auto-generate that as well. We can generate the properties, get, sets, notify a property change, and all that stuff. But this also allows us to auto-generate the XAML interop layer, the INPC implementation. But we can also generate interop layers with other UI platforms. So JNI interop to talk to Java UI, and Objective-C to talk to iOS, and that kind of thing. And with that, I'm going to hand you back over to Jason to talk more about C++ integration?
So in Office, we ended up with large quantities of native models we wanted to interact with. And we had native models, we had native types, we had all sorts of native code that really we needed to interact with from XAML and transmit to XAML. And there's a great mechanism in XAML for doing that, and that's C++ CX. But it turns out when we rolled this out to the Office team, the number one question for us was not how to use XAML or how to do a lot of XAML things. They found XAML actually fairly easy to use. But we had a lot of questions about C++ CX. So I wanted to cover sort of how we use C++ as glue between the applications. So C++ CX, or I'll just refer to it as CX because it's less of a mouthful, it really does make writing code against XAML dramatically faster. I'll show that in a second. More importantly, or as importantly, it also automates the process of generating WinMD files. WinMD files are Windows metadata files, and they define what your objects can do. When your objects are being used by C#, this is necessary for reflection type operations. The XAML compiler actually uses this to generate type info for your objects as well. It does have some drawbacks, though. CX can mask complexity or cost. It's easy to write the code. It's not always clear what it's going to be doing. And it does also have limits on how to integrate C++. It ends up being a great tool for it, but you really have to know how to use it correctly, or it'll be somewhat frustrating. It's also not cross-platform. When we ended up writing and setting things up in such a way that developers wrote all their code in their code behind, it all was C++ CX code, and that wasn't cross-platform. It was harder to unit test, and so it's another thing to be careful of. If you're writing large quantities of C++ CX code, it is not portable. But it does work great as a thin interop layer. It really allows you to not have marshalling cost and use correctly. It's really great. So to understand this, I'm going to do a sort of side-by-side. So on the left, I have a CX class. This is a ref class. This corresponds to a Windows runtime object. On the right is a C++ representation of the class, and this uses something called WRL. I'm not sure whether you're familiar with this or not. This stands for Windows Runtime Library, and it's in the SDK. All of the things I mentioned here are in the public SDK. They are not super documented, but we're going through the same code baths that you can go through as well. So I have a ref class over here. It has a public section. So I have a property and a method in this section. And what C++ CX is going to do is it's going to build an interface for you. So if you look on the right-hand side, that IFOO public non-virtuals is a generated interface that contains those methods. It turns the property into a getter and setter function, and it translates them into H results because the actual interfaces are using H results. CX will wrap things in exceptions for you. It makes it kind of nice and easy to use, but the actual underlying tech is old-school COM style interop. If you inherit from an interface, it works in an exact same way. It's just overrides. All of the stuff so far is in the actual published version of the object. So it's accessible from C#. It's accessible from outside your binary. There's another kind of scoping called internal. And C# developers may be familiar with this. This may be new to C++ developers. And internal actually corresponds to the public section of the C++ class, but not the published section. So this is not available to C#. It is not available outside the binary. But if you are inside the binary, you can just call these as public functions. So I have a native type in here. There's a little bit of a typo between the two. But the point is you can have any kind of data type being passed through as members on these functions. Finally, private works just like private. So when you're writing code inside C++ CX, it makes XAML easy. Here's some code. Take a control, set the render transforms x coordinate to 25. Pretty simple, right? It turns into the following code. You have to query over from control to UI element, then you call get render transform. This gets an object. The render transform actually will sometimes create the object, but they will cache that for you. Return the type back. You'll get an add ref release pair on that. Then you QI again to translate transform, and then finally you can call put x on the translate transform. Now, that sounds like a lot. It's actually not all that bad in isolation. The problem comes when you write the following code. Now, there's sort of a contract in virtual interfaces and in COM interfaces where people can do crazy stuff like tear-offs. Like every time you call query interface, you could return a different interface if you want. No one does, but because you could, the platform can't optimize these lines. So every one of these lines will actually repeat all of those lines above. And if you're using this in most cases, this is not a problem. But if you're using this in high-frequency code, list items are a common case of high-frequency code. So if you write this code without thinking about it, it can actually become a significant part of your performance. So when using C++ types, and as I said, for us, one of the big questions was how to integrate our legacy types. In most cases, you can use them pretty easily. Once you get the types, you can use them like you can in C++. But the question is how to get those into the object in the first place. In the same binary, use that internal scoping. You can just set them in. It's easy. But across binaries, it gets a little bit harder. We had a couple different patterns we used for this. Locator patterns, you can look up the patterns of that. You can actually reinterpret cast between object and IInspectable star and do some fancy stuff there. Really, the one we found that worked the best, it feels like a little bit of a hack, but so be it, was actually just to export set methods. You can export a method that takes a ref class and a model, and because the function executes on the inside of the binary, it can call those internal functions. So some of our scripting stuff actually generates setter functions that allow you to set things cross-binary into it. So one of the more frustrating, to me at least, limitations of C++ CX is you can't inherit from native types. So if you actually want to expose your C++ classes to Xbind, you need to find some way to wrap them. So the most common way to do this is to put a ref class around them using CX, and then you embed the class inside. So I have a sample unicorn impl class here. It has a property change notification and gets a string. So wrapping with CX is pretty straightforward, if a bit wordy. You take your base property notify changed or notify property changed implementation, and you basically forward things through. And this should be relatively straightforward to everyone here. If you actually want to use C++ inheritance, if you want to avoid C++ CX, it turns out you can do it. It's a little bit tricky and very, very non-obvious. And the way to do it is found in the way that the platform SDK itself is generated. If you look in the SDK, you'll see that there are for windows.ui.xaml.idl, there's an IDL file, there's a .h file, and there are associated WinMD files. And what happens is if you build an IDL file, and I have some example code here, you create a runtime class and some interfaces, you can run it through middle with the WinRT flag, and it will spit out a header and a WinMD file for you. There can only really be one WinMD per binary. If it's a separate binary, you can just use that. If you want to merge it in, there's a tool called MD merge. This may involve some custom build steps. It's a little tricky, but it is possible. And then once you set this up, you can use the WRL, which I mentioned beforehand, to actually implement this. So from this, you can actually compose it with your native types. You can compose it with anything. You can mix in classic COM. You can mix in other IInspectables. It's really gives you the full power of C++. Now, you don't necessarily want to do this for everything, but it's something you can do if you really have performance-intensive code. And this avoids having multiple objects. You can have a single object exposed.
All right, so I'm going to switch gears and get back to XAML a little. So in Office, we have a lot of existing resource pipelines. We have our string tables. We have huge amounts of images. We've invested a lot of time and money in these resource pipelines. And these resource pipelines were designed for classic Office. They were for Win32 Office. So these are not XAML resources. But we really want to continue to use them in our XAML applications. So XAML has a custom resource loader that allows you to basically provide an interface to XAML and say, when you need to load a resource, tell me which resource I'm supposed to load, and I'll give it to you. And that allows you to integrate your existing resources into a XAML app. Now, they basically take the string that you entered in the XAML file and give you that, which is great, but most of our resource pipelines are index-based. It's a little more efficient generally to look things up by index than string maps. So to avoid doing this extra string lookups at runtime, we actually, again, take our preprocessor to the XAML file. And if we see some markup that here we're integrating into our color resources, we have some custom markup that says, hey, if we have a brush that's called pane background, we'll at compile time replace that with custom resource brush 123. And then at runtime, we just need to do an index lookup and save the extra lookups. And so we do this with a bunch of resources. We do this with strings, colors, command IDs, icon IDs. So you might be wondering, why don't you just use an enum? XAML supports enums. Enums are integers. You can type in the name of the nice string in the XAML, and that should work great, right? Well, we actually tried this with our icon control. We have an icon control. We exposed an icon ID, which is one of our enums. And so what happens when you expose a type to XAML? XAML really needs to understand a little more information about that type. So they generate some type information when you expose a type to them. So here's what the generated type information looks like in CX for an enum. And if you look at the bit of code that's in color here, and then you imagine that maybe we exposed our icon enum, and we have many thousands of icons in Office, this might not be the best idea to do. I don't think we made our perf guys terribly happy for a little while when we did this. So as I mentioned, we created an icon control. Now we did this mostly to abstract the implementation of icon from our developers. And we did this because in the process of the release, we were changing how we do icons. On desktop, we use PNGs for our icons. And back in Windows 8.1, Windows introduced support for colored fonts, which provide various benefits over PNG files. In particular, you can support multiple different scales and stuff without having to ship a whole bunch of different versions of the same image. And then another thing that they did in Windows 10 is they moved support over to the glyph control to now support colored fonts. Now, if you're not familiar with the glyph control, I know I wasn't. It's a sort of lightweight version of text block. It doesn't support the same crazy set of text functions that text block does. But when you're just displaying an icon, you don't really need like font fallback logic and all this other stuff that text block does for you. So for icons, you should look into using glyph instead. But so we were changing this over time. Like as we got our designers created fonts for our icons. Some icons would be PNGs. Some would be fonts. And so this control allows us to hide that from our developers. And it's a relatively simple idea. It's a sort of simple flow here. The logic of what we actually do in our metadata and working out which icon we should be using when is a fairly complex thing that we wanted to keep. I mean, our bold button, for instance, it's not always a B. Some languages, it's some other letter or some other symbol. But the icon control basically looks up our metadata, decides, oh, this one's an image. I'll create a XAML image control, set that as my content. Or, oh, this icon, this is a new colored font, and so I'll create a glyph control and set that as my content. So I've talked about data. We've talked about resources. What about those document surfaces? That very custom UI in Office. Now, these canvases are highly sophisticated, dynamic, animated, interactive. You name it, this canvas has to do it. So back in Office 2013, on the classic Office applications, we moved all our rendering to DirectX, which helps this migration. We also render that content to to different 2D layers. And then we use these layers in classic desktop. We use these layers to compose the scene and to animate those different layers around to create various animation effects. Now, XAML actually has a great story here. They have a bunch of different elements that allow DirectX to interop directly in your XAML. You can put these elements anywhere in your XAML tree. You can compose them. You can animate them together. Generally, it's a very seamless integration with DirectX content. A little bit about what our code sort of architecture here looks like. We have a giant section of sort of the shared layout code, rendering code that we use, the sort of core of our applications, and that's shared across platform. And then we have an abstraction layer that we call airspace that handles the sort of creation of these layers and then the animation of those layers. In the classic Office applications, we had to write our own compositor and our own animation system to do this. In XAML, it's much simpler. We just create XAML elements, and we tell XAML to do the composition and animation for us. And then we have implementations for some of the other platforms with greater or lesser success as the platforms have better or not as much functionality for us to use. So let's talk a little bit about animations. There are really two main ways to do animations in XAML. There are theme animations, which are great. They're dead easy. You just apply a theme transition to an element, to a panel, and you change it, and then XAML animates whatever you changed. But they're fairly limited in customization. You basically get what the theme transition does, and if you don't want that, then you really have to do the other option, which is storyboards. They're fully customizable. You can do all the different kinds of animations that XAML supports. But they're fairly verbose to set up. You either require a lot of XAML markup or a lot of code. And they're difficult to make consistent across your UI. We have a lot of UI. We want animations to be consistent across it. And you can't really share storyboards across different pieces of UI. They also require custom code to trigger those animations. So I'm going to really quick show our solution to animations, which is a control that we wrote called Office Panel. And to do that, I'm going to show you our test application that we have here, which is an application where we actually require most of our developers, when they're writing a control, to write a test page in this application that allows you to test that control in isolation, manually play with it. We have some integration with our test system to write tests against controls too. So on this page, we have a little control panel for playing with our Office panel, which handles our animations for us. And so what I'm going to do here is I'm going to try changing the layout of the objects in this panel. And you'll see that the objects animate to their new positions. And all I'm doing is just changing the layout of this panel, and everything's just smoothly animating to the new positions. And I can customize the animations. So here I can slow them down a little. And now they'll animate slower. And one other thing I want to point out here is that as I'm changing the layout while they're still animating, they're just smoothly moving from their current position while they're animating to the new target that they're supposed to be moving to. And I'll just show one quick other example of this. Here we have a bunch of controls. I'm just going to add a whole pile more of controls to this panel. And they'll smoothly animate in, except this red one, which seems to be a little slower. And I can change the size of these guys, and they will also smoothly animate to their new size and then use new position at the same time. So this custom panel really gives us the flexibility of storyboards. We can use all of the customizations that you can do with storyboards. It also actually integrates with our existing animations that we have defined for desktop. We share definitions across the two platforms so we can have them have a similar feel and sort of Office experience. and we automatically trigger them on reposition, show, and hide. So how is this implemented? First thing we do is we added a couple of properties to our panel. One's the animation class, which just defines which of our animation definitions we should be using, how we should animate elements within this panel. We also have an attached property, which is a great way that XAML allows you to extend our platform. We use that to specify individual elements within our panel that should maybe use a different set of animations. And that's why that red element was going so slow, is it had a different animation class set on it. Then we just implement measure and arrange as usual. But then during arrange, we'll dynamically create storyboards on the fly to animate what changed. So here's a little segment of what arrange might look like. At the beginning here, you arrange your child as normal to its position. And then we just create a storyboard. And we animate a render transform, calculate where the element used to be, animate from that position to 0, at which point it'll be showing at its final position. And we just start that animation. So that looks great. But what happens if the position changes while this is running? If you take a closer look at this, the old position, that's where the element was going to. So if we use this code here, we'll actually, if the position changes, if we're going from A to B, and then we say, actually, we're going to C, will it immediately snap you to B if you use this code here? So our solution is actually, it's not very difficult, but it's completely non-obvious. We actually always arrange at 0, 0. We do the entire layout using render transform only. And then when we're creating our storyboards, we only need to specify the final location. We only need to specify where it's going to. And we can leave the from expression off entirely on the storyboard. And what XAML will do in that case is they will pick up the current value, even if it's in the middle of an animation. And so this allows us to smoothly change where we're animating to. So that's pretty cool. The other thing our panel does is resize animations. This is a question that I see come up both on internal aliases and externally. I see this come up all the time. And XAML doesn't really support resize animations. Generally, what people do is they start out by trying to animate the width property or height property, which XAML will kindly yell at you and say, you need to turn on use dependent animations for this to work. And what that really means is that animation is going to run on the UI thread. It's not going to run on the compositor. And so while that animation may look awesome on your developer box, when you put that on some low-end hardware, like a low-end phone, or if your UI or your application is doing something else on the UI thread, suddenly that animation will get jerky and not so smooth looking. The other option is to use scale transform. And that will run on the compositor. It'll be nice and smooth. But if you've got like text or images in your content, it'll also stretch those out, which is probably not what you really want. So our solution is again, relatively simple. But we just split our panel up into multiple layers. We continue to arrange the contents of the panel using render transforms. But then we use a scale transform on our background and our border elements. And so we can smoothly resize the sort of container. It looks like it's smoothly resizing. And then we just continue to animate the contents to handle a new layout. And so they'll smoothly animate to a new position. And everything looks great as it's resizing. And again, we just trigger this in arrange so it happens completely automatically.
So I'm going to close out the presentation by talking about where we are today. We're currently getting ready to ship these applications. They're not quite done yet, but they include Word, Excel, PowerPoint, OneNote, and new mail and calendar applications. OneNote has, of course, been in the store for some time. And if you downloaded the new builds of Windows 10, you should be able to get them from the store. So please download them, try them out, submit feedback, submit reviews. We love to get feedback on these things. It's worth noting that these are completely built on the public platform. The way we use XAML in those applications, the things we do, are all public. We don't have any backdoors or inside type of negotiations with XAML. It's all public, so it's all possible for you to do. Whether it's advisable or a little crazy is another question. But And the Windows 10 improvements are a big deal to us. You heard a lot of great things during this conference about new performance improvements, and those will help us as well. We're very excited about them. We're working to integrate them as fast as we can. And so over the next couple months, we expect the Office applications will get even better as well. And we invented our data binding replacement, but I'm going to promote Xbind one more time. If it had existed then, we would have used it. We would have, we're generating models now. We would have generated interop layers for iInspectable rather than generating complex templates that do sort of compile time type systems. They're also truly universal apps, and this was a philosophy we had, or sort of an approach we had right from the get-go. We knew we wanted to do this. We knew we wanted to be dynamic. We wanted one package for mobile and for desktop. We wanted to adapt to changes on the fly. It's important to us that we can react and you don't have to reboot the application. I don't know if you guys saw, or hopefully you saw the continuum for phones. And that's something that's really exciting for us. And so our applications will be able to shift from a phone-centric UI to a truly desktop-centric UI dynamically. As a philosophical point, we wanted to use consistent crossover points. This is similar to all of our approaches to XAML. We have a philosophy that developers should never hard code anything, like ever, because it makes it very hard to change it when you inevitably need to. And so it's really important that you don't have one app changing at 680 and one app changing at 700 and getting weird. So, establish your points, assume you're going to change things, assume you're going to change your colors, assume you're going to change everything, and set it up to make it easy to do so. And then in terms of building UI, we had a lot of sort of layering principles. The pictures I pulled up here are the same build, same version of the application. This is Word. And you see the right-hand side is what we call the palette UI, which is the phone version of the ribbon. It comes up from the bottom. The left is the standard ribbon that you would see on desktop of Universal. And those are the same controls inside. And those controls inside don't really know where they're living. They don't care. Those controls know how to render. Keeping these principles of you have elements that are loaded from data. The way you do that is relatively the same, but you can change the layout in the middle. So effectively abstract it effectively and make sure that you can dynamically swap those layouts. And lastly, code sharing is a big one for us. And Universal is built out of our main tree. It's not based on a fork. This is the first time we really were doing a mobile release out of this code tree. It's the same tree that produces Win32, same tree that produces the web applications. And actually, if you guys followed Android, the Android tablet version that was released recently is out of the same tree as well. And the universal applications are sort of a new shared code base for Office, or for at least mobile Office. And Android is built out of that same code base. So when we look at the code sharing, and these stats I'm going to pull here are from PowerPoint. But when we look at code sharing between them, we're at about 96% shared in Universal. And that includes XAML. And when you exclude XAML, we're at about 98.6. And the little bit there are platform light-ups and things like that. When you look at Android, it's 95% shared with 99.7. So almost 100% code sharing between Android and Universal when you exclude the Java UI. So this is something we're really thrilled about, and something that we want to extend and continue to grow and develop and bring the other applications and versions we've done into the fold. So with that, I'm going to refer you to a couple sessions that were done earlier. We're closing out the show here. But the data binding talk and the XAML performance talk really have a lot of great information in them. If you didn't attend those, go watch them. I also referenced here a presentation my boss actually gave at the @Scale conference, and it's worth looking at. It's the Office approach to cross-platform UI and C++ app building, and it's actually less UI focused, more just cross-platform coding. So it's worth a look as well. And with that, evaluate the session, and we're going to use the rest of the time for any questions you have. We don't have I don't think the Windows Insider Lounge is going to be available because the build is ending, but we'll be here as long as you have questions. So if you have questions for us, just come up to the microphones. And thank you. Yes.
Just a question. Do you see the C++ layer as a net positive or a net negative? I.e., if you were starting from scratch today, would you still have a C++ layer as a common layer across all your platforms?
I think we would. There is no perfect or one-size-fits-all solution. When you look at the size of Office, it's impossible to get the amount of things we do into we're fitting a huge amount of features and functionality and code into a very narrow surface. I talked about the fast bus, and desktop, considering its millions and millions of lines of code, it actually runs really fast, and it's really the power of native code that allows that to happen. And a lot of the managed solutions are really great, but we're sharing that code base with the desktop client, and C++ is one of the few languages that lets us do that. And I also think it's worth mentioning that, if you'd asked me 5 years ago how excited I was about C++, it'd be like, well, it's really fast. But it's actually evolved a lot as a language. The C++ 11 and the extensions that have been done, or not extensions, but support for that in Visual Studio are great. And something that we've really embraced and people have been excited about embracing. So I think when you absolutely need to use as little power, get as much performance, use as little battery as possible, it's to us the best solution. And it works. You can have a core that works across Android, iOS, Win32, whatever platform you might be on. And we want to have that core, we want to unit test that core, and then we want to have sort of front ends that work different ways. Yes?
I wasn't able to make it to the data binding one, but the X bind that you mentioned, is that something that's available to WPF, or is it just for universal apps?
I think it is just for universal apps. It is something that is, I think, just the XAML code base. So.
Okay.
Yeah, sorry. Any other questions? Okay. Well, thank you all, and we'll be around here if you have any more. So, thanks.